Right. So this is part of the work we've been doing with Olivier Bonami in the project on how to use derivational semantics, distributional semantics for derivational morphology. And these are some of the results. So what's the motivation for this part of the project? Well, in derivational morphology, we quite often have situations where two different processes have very similar meanings, and sometimes to the point of being completely equivalent. However, because morphology it's quite interrelated with lexical semantics, it is often very, very difficult to assess the degree of similarity between two derivational processes and to have some way of consistently evaluate whether two processes are identical or just similar and to what degree. So the idea of this project was to see whether we can use distributional semantics to automate this, and that's kind of the point we want to make in this talk. So an example of what I was just talking about are rivalry situations. This is a rivalry in English for derivational alternatives to derived verbs from nouns, which are ice, if I, ate, and just conversion. You see peasant, peasantize, trostrosify, methane, methanate, and a bundle, bundle. So these are clearly four different processes. They are phonologically different and etymologically different, but they do more or less the same thing, and they are more or less similar with each other. However, determining exactly how they are similar requires some very sharp and difficult judgments. In this particular case, Plaque argues that conversion has a series of possible meanings, shown in the first column, and that isai and ifai are basically identical in the types of meanings of morphosemantic meanings they can convey, and are a subset of the meanings that conversion can convey. And 8 is even a smaller subset, with which is a much more specialized derivational process. And similar situations appear also in French. We have this case of partial overlap between heure and voir for deriving agent, instrument, and location nouns, where the first one can only derive agent and instrument nouns, the second one instrument and location nouns. So there is some degree of overlap between both processes, and we would like to say, well, these two processes are similar to some degree, but not completely. And we want to be able to do this automatically, or at least in a more systematic way. So we're exploring the possibility of using distributional semantics to do this. I probably can skip most of the description of what the distributional semantics does for this talk. But very quickly, what we're doing is we're compiling or building the meaning of words based on their distribution in a corpus, and we represent them as vectors, and we can calculate the semantic similarity between two words as the angle between the vectors of those two words. And it's been shown that this process or this approach can be also extended to deriving or finding the meaning of derivational processes. So if we have the vector for washable and for wash, and we take the difference, the resulting vector should, in theory, have the meaning of the derivational process able. And if we aggregate and take the mean of many different pairs for the same derivational process, we should, in theory, end up with vectors which capture the average meaning of the derivational process across the vectors. And this works relatively well, and it's quite a straightforward implementation. So extending the previous concept of we can measure the semantic similarity between two words by the angle of their vectors, then we can also apply that idea to the difference vectors of the derivational processes. So in theory, once we've derived the mean vectors of the two different processes, we should be able to calculate the semantic similarity between those processes. And here's an example of what we would hope to be able to see, that the process for ISI and for IS and IFI should be very similar, or we would expect, and the vector for able should be quite different from those two. That's our expectation. And we tried to test this idea using a compilation of several different data sets for French derivation by different authors. And we ended up with a data set of 35 different processes. The different processes have different numbers of attestations of derivational pairs, with conversion being the most frequent and effectués and effectués being the least common. And then we simply calculated the difference vectors for these pairs. And we did this on a gender neutralized vector space, which we computed from a gender neutralized version of FRK. We did the gender neutralization ourselves. And the reason behind this is that gender seems to be a very strongly pervasive feature in distributional vectors. So if we do not neutralize for gender, then gender will be more present than we would want in the derivational vectors. So once we did this, we just built a simple agglomerative clustering of based on the similarity of the vectors, and these are the results. So we calculate to got it again. So we calculated the vector for each of the processes, and we calculated the distance between every process, and then we built this clustering analysis, and this is the result. And although I don't really speak French, I'm told by my co-author that this is quite reasonable. And even if one doesn't speak French, it's quite clear that the verbal nouns all are clustered together here on the bottom and are quite close to each other. Then there's another group of the verbal adjectives, which is also close to the verbal nouns, but on its own. And then we have the adjectival nouns, the adjectival verbs, and the nominal adjectives on top. So this looks quite reasonable. This looks nice, but it is relatively difficult to decide, is it reasonable enough, or is it okay but not very good? So we wanted to test this, and to test this, we basically asked French morphologists for their opinion, and we did it the following way. We wrote to 21 morphologists, and 7 gave us sent us trees, where basically the idea is that they had to simply build a tree with the 35 derivational processes, and they had to build a tree based on what they think or what they thought were the similarities between the processes. So 2 leaves should be together if they think that those 2 processes are very similar. So they are basically doing by hand what our method did automatically. And once we got these trees from the experts, we calculated the similarity between the trees the experts built and our tree. We did this by counting the number of common clusters and normalizing that count. So we have a measure which is 0 means that there is absolutely no common cluster between 2 trees, and 1 means that that both trees are completely identical. And when we compare our results against what the experts did, this is what we see. And basically, what you can observe here is that the experts don't really agree with each other, which was kind of the point of the beginning, that derivational semantics are very difficult, and it's even difficult for experts to reach an agreement on which processes should be clustered together and are more similar to each other. However, beyond that, we also see that our vectors are not particularly different from the trees of the experts, and they are not remarkable in any way. We can see that the mean degree of similarity for the tree of our vectors is just in the middle of the mean degree of similarity for those of the experts. So it's not identical to any of the experts, but no three of the experts was identical to each other. So we are completely indistinguishable from what a human is doing, at least from this quantitative perspective. So the first result of this experiment is that yes, we can use distributional semantics to capture the degree of similarity between derivational processes, and that doing this seems to give us results which are more or less coherent with what an expert morphologist would do. So that's the first bit. For a second step, we wanted to look at how well can we distinguish the different derivational processes just from looking at the vectors. So if we just look at the vectors of the derivational processes, can we predict what derivational process it will be? And the answer is that we do get a reasonable performance. This is a confusion matrix of a classifier we built. So we're basically looking at the distances between derivational processes and trying to say which of the general processes is it the adjectival noun or the adjectival verb, and this is the accuracy on the diagonal. And what you can see is that it's mostly okay. It's not perfect, but there is quite a bit of consistency, which is what we already also saw in the tree, which is that this general groupings come together because they are very similar. If we look at an example of a more fine-grained classification, here we're trying to predict the verbal noun, the verbal nominalizations, and we're trying to predict them just from looking at the vectors. And we basically see exactly what we would expect. Namely, we have very good classification accuracy for distinguishing between agent instrument and here an event nominalizations. But for distinguishing within those two subgroups, we don't perform very well. So it's very difficult to distinguish between, say, ion and ans, but it's very easy to distinguish between ion and those are very, very different. So, and then there is no confusion between them, but within these two big groups, there is quite a bit of confusion. So again, we can see that the vectors do capture some of the intuitions we would have about this sort of morphological phenomenon. Right, to the conclusions, to end the talk. We argue that we can use distributional representation for measuring the similarity between the derivational processes, and using very simple classification methods, we can actually distinguish between some of the processes from each other. The next steps we want to pursue here is we want to evaluate exactly what the vectors are capturing, because this is very difficult and we don't really know. So we know that they are representing the derivational process to some degree, but to what extent or what's the exact information that they contain, we don't know. So for now, we're just speculating. We would like to understand this better. And we also want to see how good they are actually predicting derivation. So, and we also work on some related projects, also using this idea of using distributional semantics. One is assessing paradigmatic relations in derivational morphology. These are cases where we expect that two derived forms should be more semantically similar and informative between each other than the base. And we have some initial results that this is in fact the case. And we're also using this idea of neutralizing gender in vectors to just explore lexical semantics and use that to see to what degree lexical semantics helps us with prediction of gender in French and German. And that's basically it.